Okay, so you want to set up your notes for the sun's path on page 81, and you want to write the learning objective. Student will be able to describe the daily path of the sun and explain why it changes throughout the year. So if you have, a couple of reminders. Thursday after school, lab makeups, and your homework is the Ed Puzzle video only. There's no input page. You just have to watch the video on the sun's path and answer the questions. So in class, this is what we did today. On Earth, we see the sky as a dome above us. We know that the sky continues to go on into outer space, but if you're standing here in the middle, then if you look up and you look to the sides, it kind of looks like the sky is this dome shape around us. And so if we wanted to model what kinds of things are in our sky, a lot of times we use this dome to show that. And it's kind of like being in a football arena, like the Syracuse football stadium or the Astrodome in Texas. This is what it looks like from the outside. Here's what it looks like on the inside. It's a dome, okay? And there's some vocabulary that we need to know. On your input page, an azimuth is the angular measurement of the compass directions from 0 to 360 degrees. So instead of saying north, we would say 0 degrees. Instead of saying south, we would say 180 degrees. 90 degrees would be east, and 270 degrees would be west. If you go right back up to 0 again, it could be 360. So north is actually 0 and 360 degrees. Altitude, we've talked about this a lot. This is the angular measurement of the height above the horizon from 0 to 90 degrees. If you don't have the input page, you should be writing these definitions on your input page on page 81. The horizon is 0 degrees altitude, where the sky meets the ground. And the zenith is a new term that you probably haven't heard before. 90 degrees altitude, or in other words, the zenith point is the point straight above you. So in class, I showed everybody this animation. So I'm going to pop this up here on the screen right now for you to see. All of what we see in this dome area here is the sky. Okay, we are an observer here in the middle. So there's our little stick figure guy. And I put south on the left-hand side and north on the right-hand side to model what our input page looks like. Okay, just so that it kind of looks the same. I set it to today's date, which is right here, May 16th. Now if I start the animation, you can see the sun set. And now it's nighttime for us. Now it's daytime. Sun hits its highest point. Now the sun sets and it's nighttime. Now pretty soon the sun is going to rise again in the east, go up to its highest point, and set again in the west. So this is obviously sped up in a big way. But I think a couple things are neat to notice here. First of all, notice that when the sun reaches its highest point in the sky, we have to look in the south part of the sky to see it. Okay? Notice that the sun is not rising exactly in the east, and it's not setting exactly in the west. The only time that happens is on our equinoxes. So for example, if I go back to March 21st, you should see that the sun is going to rise exactly in the east and set exactly in the west. And even on March 22nd, it's rising exactly in the east, setting exactly in the west. The other date that this happens is on September 22nd. This is the other equinox. And I know I put it a little bit earlier, but so you get the idea. The sun rises in the east and sets exactly in the west. And then we can actually change this to any date. So for example, we could change this to June 21st, which is the summer solstice. And we could take a look and see how high that sun gets up in the sky. It doesn't get to the zenith point, the point directly above that observer, but it definitely gets very high in the sky. And it's up for a long period of time. So we can see that sun, the daylight is that lasts for a long time, and then it's nighttime, but it's only nighttime for a little while before, whoop, there's the sun again. Now it's noon, and now it sets. And if you compare that to what happens in December, on December 21st, which is the first day of winter, there's a big difference. First of all, look where the sun is rising. Now it's noon, and now it sets. So the sun is not up for very long. It's dark for a long time, and it's light for a very short period of time. And also the sun is very low. It has a very low altitude, not very high in the sky, even at its highest point. And so what we're going to do today is we are going to draw a model of this, of the sun's path on those 3 special days in the year that we just showed you here. And we're going to do that on our input page in our notes. So let's start off by kind of orienting ourselves on this dome here. We're in the center of the dome, and so we would draw, I always draw a little person here, a little stick figure to show that we're in the center. And I always label it observer, so I know, aha, this is you, the observer, standing right there in the center of that dome. The other thing I want to point out to you is this horizon. This line right here is the horizon line. So I'm actually going to label that. You should label that down here on your input page. Again, if you don't have an input page, then you should draw this on page 81. Do your best to do that. And then a couple other things we should know. Everything that is in the sky we can put on this dome. This is a model of what's going on in the sky. So for example, the North Star, Polaris, we know that in New York City we are at 41 degrees north latitude. So our Polaris, we should see Polaris in the northern part of the sky about 41 degrees above the horizon. So I'm drawing Polaris on my dome here to show that that's where we would see Polaris. This is 41 degrees above the horizon, and it's in the northern part of the sky because it's the North Star. I think in your notes I made a mistake. I think I said that New York City was 43 degrees north latitude. I was thinking about Albany. Albany is at about 43 degrees north latitude, so sorry about that. And so notice that the angle of Polaris is equal to our latitude. Okay, and that's true for anybody in the northern hemisphere. That's where you would look to see Polaris. We're going to label the zenith point. Zenith point, remember, is straight above you. So we're going to put a dot there, and we're going to label that as our zenith. Just kind of want to point out to you where the compass directions are. Here's south, east, north, and west. And we set that up exactly the way it was in our animation, just to kind of orient you to that. And now I'm going to use a colored pencil. I'm going to use a blue marker. If you have a blue colored pencil or a crayon, you can use that to draw the sun's path on September 22nd on our dome. So we already said that the sun rises exactly east and it sets exactly west. So you want to draw 2 dots there to represent that. And on September 22nd, the sun gets all the way up to 49 degrees above the horizon, 49 degrees altitude. So I'm going to label that 49 degrees, and this is on September 22nd. So I'm going to label that as well. And when we draw the path, I'm going to draw a nice curved path from sunrise in the east up to its highest point. We call that highest point solar noon. So I'm going to label that. We call it solar noon because that's when the sun is at the highest point in the sky. And sometimes it's at noon, but because we switch our clocks for daylight savings time, sometimes it's at 1 p.m. So instead of saying noon or 1 p.m., we just say solar noon. That's when the sun is the highest in the sky. So it's going to be either noon or 1 p.m. depending on your clocks. And then once it hits noon, it's going to go down and set in the west. So I'm drawing another curved path, and I dashed it. I made a dashed line instead of a solid line because we're kind of looking to the back side of that dome. Okay. All right, so now one thing that you should know is that the March 21st path is exactly the same line. So we're going to label that over here on the left by just saying that it's also 3/21, March 21st. So now we've got our March 21st line. Now we're going to label our December 21st line. And I'm going to do this one in red. I don't know, red, I just don't really like winter. Red to me means no. December 21st, the sun is a lot lower. We saw that in the animation. The highest it gets in the sky at solar noon is 26 degrees above the horizon. We're going to label this 12/21 because that's December 1st. That's our winter solstice. And we saw that it's not going to rise exactly in the east. It's actually going to rise a little bit south of east, and it's going to set a little bit south of west. So again, I'm going to draw my pathway. I'm going to curve that pathway from sunrise up to solar noon. And then I'm going to make a dashed line from solar noon down to where it sets in the west. Remember, you can pause this at any time if I'm going too fast for you. And then on June 21st, the sun is going to be really high in the sky. This is our summer solstice, and it's going to get up to 73 degrees above the horizon. And we're going to label this 6/21. It's going to rise a little bit north of east and set a little bit north of west. So I'm putting my green dots there. I like to use green for June because it makes me think of green grass and trees and leaves because it's the summertime. And now again, I'm going to draw my line from sunrise all the way up to solar noon, and then a dashed line where the sun sets in the west. And that's it. So now we've got a really beautiful model of those 4 special days, the solstices and the equinoxes, and where they are rising, where the sun rises, where the highest point that it gets up to, and where it sets. So you should attach that to your input page on page 81. And then you should be all set for our output page on Friday, tomorrow. And just a friendly reminder that the homework is the Edpuzzle video. You don't have to do the input page. There's no input page. There's no notes. Just watch the video and answer the questions in Edpuzzle. Okay? I hope this helped.